just ensure that you're working from the correct Boolean expression, and the one that we've ascertained is not A and not B and C, or A and B, or not A and B and not C, or A and not B and not C. So exactly the same process as before. Start with your VSS power source. That goes at the top, and then we quickly amend that into 5 volts, so it provides the correct logic value. And then we need to feed that into a switch. So back into place basic, click on switch. Now for this one, we have got A, B, and C. So that is 3 inputs as opposed to 2. So I would recommend using a 3-input switch pack, just because it makes sense. So drag that in, and then same as we did previously, join up all of the inputs. So your first switch is going to be input A, second switch will be input B, and then your last one will be C. So when you turn it on, we've got basically A, B, and C. Now looking at our Boolean algebraic expression, we can now start to look at what gates we're going to need. Click on your place MISC digital, and we're going to start with expression number 1. So this is not A, not B, and C. And we're going to start with some NOT gates. So type in NOT, and we're going to put them across here. So that's going to be not A, not B, like that, and then C is on its own, so you don't need to worry about C. We're then going to feed them into an AND gate. So same process, MISC digital, AND, like that. Now again, to make it easy, we're going to use 3 input AND gates, and we'll pop that over there. So essentially, A will feed into this one, and that'll go into there. You can stagger them if you want to make a bit more space, like that. B will go into this one, like that. And then C will go into this one, like that. Now, in order to differentiate between A, B, and C, if you want to be quite fancy about it, you can actually change the different colours by right-clicking and going into segment colour and changing your A, B, and C. This is useful if you want to do some fault finding further down the line. So if you're not entirely sure why your circuit is not working for whatever reason, you can change the colours, and it makes it easy to figure out which one's A, which one's B, and which one's C. That's the first one taken care of. We're literally going to repeat this process for the next 3 expressions. Now we can speed this up a little bit by copy and pasting your gates. So if you click on your AND gate, press Ctrl C, you can then just copy and paste it further below. Now I've done that for the next couple of AND gates, and then what we can do is just basically link them up the next way. And also a little trick to speed things up a little bit, because your second expression uses not A, you don't necessarily have to have its own separate NOT gate. You can steal it from this one up here. So that will still be not A because it's fed from your A switch, and you can feed it into there. So that's not A for this one. B we'll just take from B there. You can't go after the NOT because otherwise you'll get the incorrect signal. And then for this one it's going to be not C. So we will have to put our own NOT gate in for this component. So that goes in there, and this will become not C, and we will connect it up off of C, which is that one there, the green one. I'm going to change that colour to green just so it ties in with the rest of our design as well. Now similar for this one, last one, it's A, so straight from A, and this one is not B and not C. So for this particular one, not B can be stolen from here, and not C can be stolen from there. Separated by an OR gate, so we will need to go in and find our OR gates. Same as before, MISC digital, type in OR. We'll need an OR3, so a 3-input OR gate. pop that there. Feed your AND gate outputs into the inputs of our OR gate. And then that will also require an indicator. I'm going to use blue because it's my favorite color. Pop that into there. And that should be done. Now to test it, we're going to press play and then follow the truth table. So our first one, if we turn C on, that should light it up. Turn that off. If we turn B on, that should light it up. So that shows that it works. And then if we turn A on, light it up, that shows that it works. If we turn any other combination on, so all on or 2 on, for example, your light will go off. And this proves that if we follow the truth table, your circuit will work.